Hello and welcome. This demo will showcase interoperability between astronomical tools achieved via the use of the SAMP, Simple Application Messaging Protocol, developed by virtual observatory organizations from across the globe. Let's start with a very familiar tool. You've all no doubt used Google Earth to explore the surface of our planet, even if only in your immediate neighborhood. Here, you can see a satellite image of the building where I work, the Center for Astrophysics in Cambridge, Massachusetts. You may not be aware that you can also utilize Google Earth to explore the sky overhead. You can switch to Google Sky with a simple mouse click. Now we can see the region of the sky that is overhead at this moment. We can zoom in and zoom out. The background imagery here is provided by the Sloan Digital Sky Survey. In addition, the constellations are plotted on the sky. Let's go to an extremely interesting place, the constellation Orion. Orion, also known as the Hunter, is justifiably famous because of the many objects of astrophysical interest that lie within its borders. Here's Betelgeuse, the 8th brightest star in the sky and an example of a red supergiant. And Rigel, a blue supergiant which is renowned for its twinkling. It's typically low in the sky in northern latitudes, and its steely blue color. However, the most interesting source from an astrophysical point of view is the nebula M42. This is the brightest star-forming region in the sky. It's visible with the naked eye from clear, dark skies. Zooming in on this object, we can see that at the very center of the field of view we have a different view or image of the nebula in visible light and in much higher resolution than the surrounding image. This inset image is provided by the Hubble Space Telescope rather than the Sloan Digital Sky Survey. This exquisite image allows us to appreciate the complex structure of dust, gas, and stars at the center of the nebula. For this demo, we'll use an image from another space-based telescope, the Chandra X-ray telescope. X-rays are among the more energetic wavelengths in the universe. The Chandra X-ray telescope has allowed astronomers to delve into very energetic emissions of the universe at an unprecedented level of spatial resolution and depth. We can have a look at the data available from the Chandra X-ray telescope from within Google Sky by loading the Chandra Science Data layer. Clicking on this box brings up a range of different kinds of objects in the sky, overplotted on the main display. Now let's take a look at the various kinds of information available. I'll unselect the Chandra Science Data layer, then select only the Images layer. As you can see, the X-ray images have been plotted over the optical images, specifically where Chandra observations have been made and are available. It's interesting to note how the same region of the sky has completely different appearances at different wavelengths. We can change the transparency of the X-ray images to highlight these differences. It's easy, for example, to see that in visible light, the center of this nebula shows few stars, while at X-ray wavelengths, the very energetic emissions from stars is able to pierce the gas and dust, and we can see many more stars. But this is not the only kind of information available from the Chandra Science Data layer. If we select Fields of View, we will see a collection of rectangles, footprints, in effect, of the different observations obtained by various scientists with the Chandra telescope. These rectangles are the projection of the Chandra detectors onto the sky. If we wish to know more about one particular observation, we can click on the rectangle, and a link to the web-based Web Chaser application will allow us to see a summary of the most important parameters of that observation. the observation ID, the instrument used, and the name of the principal investigator. More information can be obtained by clicking on the View Observation Information button. Both a short and a more detailed summary of the observation are available. Perhaps most interestingly, we can access a listing of all known publications in the scientific literature which make use of or simply reference this data. This is a service offered by the SAO NASA Astrophysics Data System, or ADS. But let's get back to the sky. As I told you, footprints and images are not the only available information. Another important piece is the individual sources detected in the X-ray images. Let's zoom in. For most of these sources, a set of observational parameters is available from the Chandra source catalog. To see where the Chandra source catalog sources are located in the sky, simply click the Master Sources layer. Now, all the sources contained in the Chandra source catalog are marked with a yellow CXO symbol. Clicking on one particular symbol reveals a summary of the most important information about the source. However, if we are looking for additional information, or say data on a set of sources, we can go to the web page of the Chandra source catalog, where we can find information about the Chandra source catalog itself and a range of ways to access the data contained within it. Very simply, the CSC collects all manner of data produced by the Chandra X-ray telescope: images, light curves, spectra, event files, and tabular data. We can access this database in different ways. For example, CSC View is a graphical builder for queries to the Chandra source catalog database.